Welcome, Eduardo. Eduardo is interested in developing tools to deliver reliable machine learning products. Towards that end, he developed Plumer, an open source Python library for reproducible data science, first introduced at JupyterCon 2020. He holds a Master of Science in Data Science from Columbia University, where he took part in computational neuroscience research. He started his data science career in 2015 at the Center for Data Science and Public Policy at the University of Chicago. Eduardo is going to talk about effective testing for machine learning projects.
Yes, that's correct. Awesome, great. So let's get started. Thanks everyone for joining today. We are going to be talking about effective testing for machine learning. My name is Eduardo Blancas, and I'm really happy to be here. So thanks for joining. Let's start with this presentation. So before we get into the details, I want to kind of discuss the motivation for this talk, because why should we bother about testing, right? You come to a talk, and I'm going to be talking about testing, and why should we bother about these things? And over the years, since I've been working on many different data science and machine learning projects, I often ask this question to other people to say what they think. And sometimes they give these kinds of really valid answers, and they say, well, I don't have enough time, right? If I'm working on a model and I want to improve that model, testing is going to slow me down, and I'm not going to be able to run enough experiments. And that's a really valid concern. Sometimes they say, I don't know how to test these things. It's very different to test, let's say, an API from a regular web application. It's much difficult to think, how do I test a machine learning model? So these are really valid answers and concerns. So the idea of this talk is to give some of my perspective of what I've learned over the years, and maybe you can take some of these and apply to your projects. And really the question should be, where do you want to find the issues, right? Because we are humans, we make mistakes. So if you don't test, you're going to find those issues in production. So do you rather test to find them in development or production? So I think that's really the question that we should be asking. And another thing that I've learned over these last few years is that when you start testing and you feel comfortable adding tests to your code, it really has, it increases your productivity, because you are able to confidently make changes to your code without worrying, am I going to make some mistake? Am I going to drop the performance of my model because I introduced some error at some point? So really having these tests allow you to say, okay, if my tests are passing, then it means that I'm making good progress. So I think the bottom line from this slide is it's important and it helps you in the long run. So please test. Now, why am I calling this an effective approach? Because I feel like, based on my experience, we have to find a good balance between training lots of models and experimenting, trying out new features, and at the same time add some more robustness to our pipeline. So they go hand in hand. It's not like we are going to spend 100% of our time developing models and then just add a few tests at the end, because that's not a good strategy. What we want to do is to do some modeling, then add a few tests and continue working. And the idea is that by the time you are you want to deploy your model, at that point, you have a really comprehensive and robust test suite. So that's the idea here. Now, before I start talking about this practical framework, I want to introduce some really simple concepts that I'm going to be using throughout the presentation. The first one is a pipeline. And a pipeline is a really simple concept. It's just a set of tasks that have certain order of execution. So if we talk about a machine learning pipeline, we may have the basic structure of a machine learning pipeline is we get some historical data for training purposes. We get some historical data, we generate some features, and then we train a model, right? Like really simple standard things. Now, inside the pipeline, we have tasks, and a task is just a unit of work. It can be a function, can be a script, can be a notebook. It's kind of an arbitrary definition, but we organize our pipeline in small tasks. And it's really important to do this, to organize them in small tasks so we can test them in isolation. So just bear in mind that this is like a really generic definition, but it's useful for our purposes. Now, if we mention the pipeline concept, we also have to make some important specification for the machine learning projects that we work on, and is that we usually have two pipelines. The first one is the training pipeline, which is what I mentioned before. We get some historical data, we generate some features, and then we train a model. Once we have that model, we want to use that to make predictions. So now we have our serving pipeline, which is pretty similar actually. But instead of getting historical data, we get new data. Those new data points that we want to use to generate predictions. And then we generate the same features, we apply the same pre-processing, and then we use our model to make predictions. So as you can see, this part in the middle is the same thing. And it's really important to make that specification because we want to make sure that the pre-processing is the same at training and serving time. And I'm going to mention this again in one of the last stages of the presentation. It's a really important distinction. Now, the code that I'm going to be using for the presentation is available on GitHub. So you can maybe get it now and take a look at some of the code, or you can just follow the presentation, and maybe after the talk, you can get the code and play around with it, run it, break it, and see that you are able to run the tests. And I also configure GitHub Actions so that you can see the continuous integration thing. So hope you can get the code and enjoy and play around with it. So now let's get started with the actual framework. And I developed this framework over like a couple of years. I couldn't find like a really clear way of explaining how I was testing my code until like a few years of experimenting, trying out new things. And I think I finally, after a few years, I got this clear idea of, okay, we have to do this in different levels. And as we make progress, we generate more robust tests. So I think this is I would say this is the summary of my experience. And that's why I want to share that with you. So we are going to have 5 different levels. And the idea is that as we make progress on our project, we want to keep increasing the robustness of our tests. So let's start with the first one. The first one is called smoke testing. And this is the most basic type of testing that we can apply. And it's called smoke testing because we are not testing the output. We are not doing anything specific. We are just making sure that our code runs. So this is the most basic thing. Imagine you just started working on a machine learning project and you have some code that maybe gets some data, cleans some data, you generate your first couple features. You want to make sure that you are able to get a clean server, install your dependencies, and run your code. Now, a really important question that you may have is, well, if I have 10 gigabytes of data, or maybe even more, like 1 terabyte of data, how am I going to be testing this continuously? Because the idea is that you should be testing every time you push to your repository. So that's a really important thing. You should be testing continuously with each change. So you might be asking, how am I supposed to test my stuff if I make 20 commits a day? Well, the answer is really simple. You can test with a random sample. So if you have 1 million observations, just grab a sample of 1% or even less than that and test with that. Because remember, right now, we are not worrying about the output of our code. We simply want to make sure that it runs. And just to make this concept a little bit more clear, I'm going to show you how this looks like in practice. So on your left side, you have the configuration file that I'm using on GitHub to execute certain code every time I push to my repo. And I have a 1 branch per level. So you can see on your right side that I'm in the first branch. So 1, smoke testing. And this is how my code looks like. My actual code is on a notebook. The details aren't important. So just keep this in mind. All my work is in a Jupyter notebook, and I get some data, and I train a model, and that's all I have right now. So what I'm doing here is I'm using Plumber, the project that I'm working on, which allows me to quickly run my notebook to make sure that it's working. So this is GitHub Actions, and we can ignore the details for now, just focus on this part. What I'm doing is every time I push to GitHub, I'm going to install my dependencies. You can see that name, install dependencies, and then I'm going to run my pipeline. That's it. That's all I'm doing. And this really simple trick is a huge progress for testing. I'm just making sure that things run. That's why it's called smoke testing. Okay, so moving on. Now we go to level number 2. Maybe at this point you have more features, maybe you even have your first baseline model. So you should be thinking of how do I make sure that the data that goes into my training pipeline is of high quality. Because if you have issues with the data, can be issues from the source. Maybe the data collection process isn't good enough and you have some corrupted data. That can happen. So at this point, we start to think about the quality of the data, of what goes into our training pipeline, but also how can we make sure that the transformations that we apply to our data are implemented correctly. So this second level has two objectives. The first one is prevent low quality data from entering our training pipeline. And the second one is that we want to detect issues with our data transformations. And our data transformations can be something like a group by, and maybe we are doing some other small tweaks to the data, and we want to make sure that those are implemented correctly. So now let me show you how this looks like in practice. Let me go to my file. And since we have limited time, I'm not going to be showing all the files. I'm just going to be focusing on, I have to change my branch first. Okay, to integration. That's why I couldn't find the file. Okay, tests, quality. Okay, so just to give some more context of what this sample pipeline is about, I'm using the heart disease dataset. That's a sample dataset. And I got this really nice notebook from Kaggle. And then I started just adding some tests. So what's the idea? In our pipeline, we have a script that cleans the raw data. So we apply some transformations, and the output of that clean script is our clean data. Now, the definition of clean data is subjective, and it also depends on the specifics of our data set. So it's up to us as a data scientist to define what clean data means. Now, we may say, for this data set, we have an age column and we have a sex column, right? That's how the data is. And we may define some things like, okay, if this data set has one person per row and we have an age column, one sensible thing to say is that all the observations, all the values on this column should be at least 0, right? That's a good rule to have. Now, we should automate testing for these kinds of things because it might be the case that we check our data when we are exploring. We have some Jupyter notebook, we are exploring data, and we check that. We say, okay, everyone in our data set has an age of like between 20 and 70, just to say something, right? And it makes sense. But what happens if we make some mistake in our transformations, or we get some corrupted observations from the data warehouse? We have to make sure that every time we train a model, we have these rules in place, because these are kind of stop checks that prevent us from training on low quality data. And I'm implementing this with Plumber because it allows me to run something and then run this function that checks the output of that script. But you can really implement this with any framework. You just have to like have that concept clear. You have some script that produces some output, and now we want to check how the output looks like. Now, I also mentioned that this is integration testing, and some people also call it data quality testing. So it's the same thing. I also mentioned that at this point, we are going to start incorporating unit tests. And this is like a really traditional, like well-known concept. So imagine that you are developing some data transformations and that you have a column that has an integer, for example, here. Let's imagine that these are the values that you have for that specific column. And then you want to convert those values to some human readable representation. And I got these values from the documentation from this dataset. Now, this is a really simple transformation. So in many cases, if you are just doing like a really simple stuff, might not be worth your time to write a test if you have 1 or 2 lines of code, right? Especially if you're using some other framework like Pandas that you know have correct implementations of all these things. But whenever you have some custom transformations or like some really specific logic, it's really important to write some unit tests. And a unit test works like this. You have a function, right? You have a function that does something with some input. So to write your test, you define some input, and then you define what's the expected output of that function given this input. And then you call that function with that input and verify that it's the same thing that you expected. And if this happens, then means your tests are working. If this fails, then it means that you should go back to your implementation and see what's going on. So I can show you how I can run my unit tests. I only have one, but you should be implementing this for all your custom data transformations. I'm using this library called PyTest, and I can execute PyTest, and it can run. It runs my single test, and it says it's working. So I'm happy. My implementation is correct. So we can move on. Okay. So let's go back to our slides and talk about the level number 3. So this is where things start to get serious. And we start to write some more robust tests. So when I talk about integration testing and data quality, one of the things that I mentioned is we can check some of the values in our columns, or for example, if it's a categorical variable that we may only have 2 or 3 values and we can test for that. Or if it's like an age column, we should expect that to be larger than 0. But these are really basic things, right? We are not saying, we are only making assumptions about each individual column, but we are not saying anything about the overall population. And changes in the data distribution can break our models. So imagine that we are training this model that predicts heart disease, right? And we have information on, let's say that focus on this first curve that we have here. And imagine that we have something like this, that our data set has people who's between, like the mean of this distribution is 50 years old. Right? That's fine. We train a model, we evaluate performance, and it works fine. Now, we want to retrain our model. Let's say we got some new data. We got some more recent data from, let's say, 1,000 new people. And then our distribution looks like this. This is a really drastic change. And it can be valid. It can be that simply we are collecting data in a different way, and that's just how it is. We have to adapt to the change, but it can also be an issue. And we don't know. And if we don't know, the best thing to do is to make sure that we detect these types of changes. Like if we have some key variables that we need to pay close attention to, we have to make sure that whenever these have drastic changes, we test for that and raise an issue, an error, if that's the case. So that's the first part. The second part is that we are going to start testing our serving pipeline. So at this point, we may have a good model, a model that we want to take to production, that we want to use for making predictions. So we are going to start adding these distribution changes tests, but also we are going to make sure that we can train a model, we can take that model file, and then we can generate predictions. So let's see how the code looks like. Let me move to the next branch. Okay, so the first thing, let me show you how the configuration file for GitHub Actions looks like. First, we run our unit tests, and the order is important here because the unit tests are supposed to be fast. So if they fail, we're going to stop execution right here, and it may take like 1 or 2 minutes, and that's great. We want to fail fast. If things are breaking, we want to know as soon as we can. Then the next thing that we do is we run our training pipeline. And remember, we are not checking. Well, at this point, we are checking some of the properties of our data. So if you want to sample your data to make things faster, you can still do it, right? If you are checking the distribution of your data, these changes in distribution, you can also detect them with a sample of the data. But maybe you can run this instead of on every commit and push. Maybe you can run this every night or every week, whatever works for you. And then what we are going to do is we are going to run our serving pipeline. So check what's happening here. I am training a model, and then I'm taking that model, and then I'm running my serving pipeline. So of course, I'm using this library, so I'm not going to go into the details because that's going to take too much time. But just take that idea. you train your model, you take that same model and then put it inside your serving pipeline and make sure that you can generate some predictions, can be with some sample data that you have. You just want to make sure that you can actually take that model and generate predictions. Now, I'm going to show you the example of this distribution changes test. So remember in the previous level, I told you about these data quality tests. The changes in distribution are just an extension of that idea, but we are testing a more specific thing. So here, what I'm running is I'm running a statistical test. The details, you can check the details on Wikipedia, but the high level idea is that if the distribution changes too much, I'm going to set a threshold. And if that difference goes beyond that threshold, I'm going to raise an error. We are expecting changes to happen. Like if we have 100 observations and tomorrow we get 10 new observations, it's natural that we are going to see some small changes in the distribution, and that's fine. And we don't want to raise issues for those or raise errors for those small changes. So that's why we set a threshold here. Here we start to think about these kinds of thresholds, which, to be honest, are hard to set. But my recommendation is keep things simple, come up with some threshold, and if it doesn't work that well, you can adjust it. So that's why this is like a really practical framework. Like we want to make things fast, we want to make things practical. But if things don't work for you because you have a complex data set, you may have to tweak these kinds of tests for your use case. Okay, so moving on to the next level. We are now at level 4, which is one of the most important things to do. So make sure that you create this test before you deploy to production. So let's recap our definition of training and serving pipelines. The training pipeline generates a model, a trained model, and the serving pipeline takes that model and generates predictions, right? But from the moment we get the data until the moment that we either train a model or generate predictions, we have to apply some pre-processing. And we have to make sure that that pre-processing is the exact same thing at training and serving time. And to give you an example of what can happen is, let's imagine that we get some data point, and that data point is 1, 2, 3. We pass that data point through our training pipeline. This is before we train the model. This is the feature vector that we use for training the model. And we get an output of 10, 20, 30. Okay, now we take that same data point, we pass it through our pre-processing for serving, and we get 10, 20, 40. This is a problem because given the same input, both our training and serving pipeline should have the same output. And this is a really common problem, and this happens many, many times. So what we do is we generate some, or it can be some sample data from your training set, or you can generate some synthetic observations. It's the same thing. What you have to test is you write a little program, you write a test that takes some input, passes through your training and serving pipeline, and then check that these values are the same for, I don't know, like 10, 20 data points, or even more if you can afford a larger running time. So this is a really important test to have. I'm not going to show the code because it has a little bit more details, but you get the general idea. So really important test. Now we are, this is the final level in our framework, and here we are going to start testing model quality. So this is really, really important. And also you have to make sure that before you go to production, you have this test in place. So let me go to our code and quickly move to the last
Hey, Eduardo, just a quick heads up. We have about 5 minutes left.
Okay, yeah, almost done. Thanks. Okay, so this is the idea. We have to make sure that everything that comes out from our training pipeline is a model of good quality, right? Because many things may happen. We may, imagine, accidentally we remove some of the most important features in our model, or we leak some information from the future, information that we are not going to have at prediction time. Like there are many, many things that can drop the performance of our model. And if we are not closely monitoring these changes, we can deploy models that are not of high quality. So really simple idea here. We train a model, we get the predictions. This is from our evaluation set. We get the predictions, we get the actual values, and then we test that some metric, the specific metric depends on our model. We check that the metric is within certain range. And it's important to make it between, have like the two bounds, the lower and the upper bound, because if a model suddenly drops in performance, that's a bad thing. If it's suddenly, it's like crazily good from one moment to another, then that might be great news. I'm sure it's because you're a great data scientist, but even great data scientists may make mistakes. So make sure that if you get high increases in performance, is because you had some greater model instead of doing some mistake, because it happens to everyone. So how do you come up with this range? I mean, to be honest, it's kind of arbitrary, and I would recommend you to just kind of draw some reasonable range. And if it works for you, then that's fine. If you have more complexity, like same thing that I mentioned before, if your project is more complex and you have more stuff going on, you can revisit some statistics books, or you can chat to me, and I'm always happy to talk about these kinds of things and come up with some more statistically principled way of drawing these boundaries. But this is the simple idea. Test the performance of your model. And here are a few resources just to end the presentation. You can get the code from here. And I'm going to prepare a blog post from all of these presentations with more examples, with more details. So please keep an eye on the blog. You have that here. If you want to check out Plumer, which was the framework that I use for the code examples, you can also get it on GitHub. And I'm going to take questions now, but if you want to ask anything after the conference, you can reach out to me on Twitter. And that's it. We still have a few minutes for questions.
Thank you so much, Eduardo. We have a question from Philippa. Do you run the tests in different branches?
That's a great question. I think it depends on how many people are working on that project. If you are collaborating, then it would make sense to have like different features, different branches, and then when you merge, you run everything. So I would say it's more like a team strategy.
Okay, and Philippa also would like to know if the data quality integration tests need to rerun for the entire data set.
Yes, that's also a great point. I would recommend you to run them with a sample every time you push. But if you can allow, maybe run these integration tests on like every night or every week, if you are dealing with like large data sets, that's also a good idea.
Okay, thanks. Patrick would like to know, you showed some GitHub actions. Are you running all these tests remotely? If so, for example, for the data quality checks, how do you store your data sets?
That's an important question. And I kind of skipped that setup to simplify the examples. So what I'm using is a really sample data set that has like 100 observations or so. In a real setting, then you would have to think about the infrastructure, right? How do you make sure that when you push your code, whatever computing infrastructure that you are using is able to get your data and then run your code? So that's a really important question. I would say that's more like in the infrastructure side, but that's definitely something that you need to think of when you implement this framework.
Okay. Thank you, Eduardo. There are so many great questions, and unfortunately, we didn't have time to answer all of these. But I want to thank you for being a part of PyData Global 2021. Thank you so much.
Thank you. Bye.